The hurricane struck off the coast of the Carolinas in September 1857, driving seawater into the hull and snuffing the boilers that powered the steamer's pumps. The Cessa Central America carried nearly 600 souls and a commercial shipment of California gold valued at the time at over $1 million, often cited as roughly $1.2 million in 1857 terms. At a moment when Eastern credit was already strained. When the vessel foundered, it took the bullion and hundreds of passengers to the bottom, helping to deepen the financial panic of 1857 already gathering force. For more than a century, the wreck lay silent, protected by a barrier more effective than any vault, the crushing depth of the Atlantic. And when the technology finally caught up, the first obstacle wasn't mechanical, it was informational. The precise location had been smeared by survival, panic, and weather into a set of competing truths. A passing rescue ship logged one position. The sinking ship's officers, working from a deck tilting under hurricane seas, estimated another. Storm drift turned both into moving targets. Searching the entire potential area with sonar was operationally impossible. The grid was too vast, and every day at sea burned money faster than certainty. To solve this, the project directors applied Bayesian search theory. Instead of treating the ocean as a blank slate, they assigned probability weights to every piece of historical evidence. A celestial fix from a stable rescue ship was graded high. A dead reckoning position from a ship listing in a hurricane was graded low. The result was a set of probability search maps, guiding the survey to prioritize the most likely cells and spend little time where the odds collapsed. The survey phase deployed side-scan sonar towed on a cable miles long. This introduced a physical constraint. The towfish had to fly close to the bottom to see detail, while the surface ship rode the Atlantic swell thousands of feet above. Between ship and towfish, miles of cable hung in a springy curve. Speed and altitude had to stay in a narrow band. Pull too hard and the sensor climbed, too low and it brushed the seabed. The crew held a disciplined, measured trawl, scanning the high-probability cells strip by strip. On September 11, 1988, the sonar returned an anomaly that broke the geological pattern. It was not a rock formation or a Cold War relic. The acoustic shadow hinted at the chaotic architecture of a 19th-century shipwreck, including the outline of a collapsed sidewheel. But sonar was only the first proof. The team returned with tele-operated cameras to confirm what the pixels implied, and the identity locked in. The Central America was there, more than a mile down, resting on the sediment. But the coordinates were only a beginning. The site itself was a locked door with no human key. Down here, pressure climbed into the thousands of pounds per square inch, far beyond any diver. And the tools of the era weren't built for careful work in a fragile debris field. A submarine could arrive, but not handle. A dredge could reach, but only by erasing what it touched. What the recovery demanded was something new, a machine that could survive the abyss and still move with restraint. The engineering challenge was not merely static pressure, but the complete denial of direct human intervention. In shallow salvage, a diver can feel a grip shift, brace against a surge, and correct by instinct. Here, the operator worked through a fiber optic tether, with distance measured in a full mile of seawater. No touch, no peripheral cues, no second chances. The signal delay was negligible, but the sensory deprivation was absolute. Standard robotic vehicles of the era were built for industry. Agile inspection swimmers meant to watch valves and drill heads, not to stand their ground on a soft seabed. In heavy salvage, a platform that is too light, too buoyant, or too thruster-dependent can be bullied by reaction forces, pushed into the mud, yawed off target, or bounced out of position at the worst moment. To overcome this physics deficit, the recovery team bypassed off-the-shelf solutions and designed a custom vehicle from the keel up. What they needed was a machine that could land and hold its ground. The answer was mass and intent. Christened Nemo, the machine was a leviathan by industry standards, tipping the scales at 12,000 pounds. That weight wasn't a drawback, it was the point. Nemo was built to settle onto the seafloor and work from a planted stance, resisting the pushback that would shove lighter machines around, less a free-swimming sub, more a crane lowered into the abyss. A stable platform, however, solved only the kinetic half of the problem. The visual barrier remained. The standard method of piloting a remotely operated vehicle involved watching a flat, two-dimensional video monitor on the surface ship. This limitation stripped the pilot of depth perception. In a chaotic debris field, the inability to judge the z-axis, the distance between the claw and the target, often led to disaster. A pilot might miscalculate by 3 inches, driving the manipulator into the sediment. At this depth, the bottom is composed of fine, light silt. A single clumsy impact kicks up a cloud of black smoke that takes hours to clear in the stagnant bottom water, forcing the operation to halt. The engineers countered this by integrating what they called telepresence. Instead of a single camera, Nemo carried stereoscopic cameras spaced to mimic human vision. On the surface vessel, the pilot used a stereoscopic viewing system that fused the paired feeds into true depth. The result wasn't magic, but it changed the work. In a debris field where inches mattered, the operator could place the manipulator with confidence, steady, deliberate, and repeatable. Deploying Nemo was a heavy industrial operation. The launch sequence swung the chassis out over the stern of the Arctic Discoverer, then paid out the armored umbilical. The descent through the water column took over an hour, a long commute through the darkening zones of the ocean. During that time, station keeping wasn't seamanship theater, it was survival for the tether. A small wander at the surface could translate into a sweeping arc below, loading the line and stealing control right when the vehicle needed it most, at touchdown. When Nemo finally illuminated the target zone, the efficiency of the heavy lift design was immediately tested. The lights revealed the Garden of Gold. Much of the ship's wooden structure had collapsed or decayed over 13 decades, exposing portions of the heavy cargo on the sediment. Coins were not merely present, they were scattered in drifts like spilled metal frozen in place. Gold bars mingled with the remains of the hull's coal supply. The site was rich, but richness brought its own complication. Reaching the vault was one thing. Securing what lay inside, without raising that black smoke, was another. In that garden of gold, the real constraint wasn't beauty, it was physics. Gold is 19 times denser than water, meaning a small ingot that fits in a human palm can strain standard robotic joints. That density also sorted the site vertically. The heavy bars settled hard into the seabed, while lighter debris drifted over them. The recovery plan had to treat the field as 2 different problems at once, the massive commercial ingots and the thousands of smaller coins scattered like gravel. To handle the ingots, Nemo relied on its primary manipulator, a hydraulic work arm nicknamed Dexter. This was not a simple open-close clamp. It was built for controlled, deliberate pressure, strong enough to secure heavy bars, but precise enough to avoid grinding artifacts into the sediment. With careful piloting and stable footing, the arm could tease an ingot free, lift it clear, and stack it into recovery baskets, effectively reversing the loading process of 1857. The coins presented a different bottleneck. Picking up thousands of individual pieces one by one with a robotic claw would have stretched the project into years, but brute scooping would be its own disaster. Too much sediment, too much contamination, too much work pushed uphill to the surface. The solution was a suite of specialized collection tools, precision suction, and gentle pickup devices tuned for control, not force. In the right patch of sea floor, a single pass could gather dozens of pieces and slide them into a protected drawer. Day after day, the baskets came up. The volume of recovery was staggering. In this initial phase, the team brought up more than 2 tons of gold. The haul included hundreds of heavy bars stamped by California assayers and thousands of double eagle coins, many remarkably well preserved, some showing their original luster only after careful conservation. The concentration of wealth confirmed the location of the ship's strong room. The salvers had tapped the commercial artery of the 19th century economy. Success, however, generated a signal loud enough to reach the courtrooms of the mainland. As the value of the recovery became public, 39 insurance companies entered the case. These firms, or their historical successors, argued that they had paid out claims on the cargo in 1857 and therefore retained title to the gold. Under maritime law, a valid insurance payout can maintain ownership indefinitely, preventing the wreck from being classified as abandoned. The salvers argued that the insurers had long since written off the loss and destroyed the records. The legal collision moved fast into federal court, and the ocean became a courtroom exhibit. The judge carved out an injunction box on the seafloor, rules meant to keep rival salvors from swarming the site while the case unfolded. Recovery did not become a simple stop-and-go switch. It became a campaign under legal restraint, paperwork, and scrutiny, where every lift had consequences beyond engineering. And while the gold already on deck could be secured, the non-monetary targets, the personal effects and passenger luggage, still waited below, vulnerable to disturbance and time as the litigation ground on. While the gold bars presented a challenge of mass and density, the debris field held a second inventory that posed the exact opposite problem: extreme fragility. In a typical shipwreck, the ocean is a biological incinerator. Wood borers, bacteria, and oxidation erase the organic world. Within decades, here the deep sea slowed that burn. Cold water, fine sediment, and low oxygen pockets inside sealed containers throttled decay. The result was a cruel illusion. A Victorian trunk could look upright and intact as if it had settled yesterday, but structurally it had the consistency of wet tissue. If the pilot lifted it with the same hydraulic force used for gold ingots, the steel claw would simply shear through the artifact. The recovery demanded a method that could apply lift without concentrating pressure. The engineering solution was to bypass rigid mechanics entirely in favor of soft-touch technology. The team developed a system utilizing silicone, a material that could remain flexible even in the near-freezing temperatures of the deep ocean. Nemo was equipped with a specialized injection system and manipulators fitted with custom-molded silicone fingers. These grippers were compliant. They did not crush the target but conformed to its irregularities. When the pilot approached a rotting satchel or a delicate safe, the silicone fingers would gently envelop the object. The lift relied on high surface area friction rather than a vice-like grip. This allowed the robot to cradle items that would otherwise disintegrate under their own weight if handled roughly. The primary targets of this delicate operation were the personal effects of the passengers, specifically the photography. The mid-19th century was the dawn of the daguerreotype and the ambrotype, images captured on silver-coated copper plates or glass, sealed inside protective cases of wood and leather. The anaerobic mud had prevented the leather cases from rotting away, keeping the glass seals watertight. Nemo successfully recovered these small, block-like artifacts, placing them into padded drawers to protect them from the vibration of the ascent. When the artifacts reached the surface, the preservation work transferred to the conservation laboratory aboard the Arctic. Discoverer. The cases were often covered in black sulfide deposits, looking like nothing more than lumps of coal. However, as the conservators carefully cleaned the glass and stabilized the plates, the images emerged with startling clarity. Time had been held back just long enough for the faces to return. The collection included dozens of portraits: young women in lace collars, stoic men in formal coats, and families posing for a voyage that was supposed to end in New York. These were not stylized paintings, but high-resolution reflections of the people who stood on the deck in September 1857. The gold stacked in the hold paid the operational costs, but the recovery of the daguerreotypes achieved a forensic resurrection, pulling the victims back from the anonymity of the ledger. The transition from the seabed to the surface laboratory shifted the operational focus from hydraulic engineering to forensic chemistry. Once the recovery baskets were on deck, the preservation clock started ticking. The organic artifacts, having equilibrated to the high-pressure, oxygen-free environment of the deep, were now exposed to the atmosphere. To prevent rapid degradation, the conservation team kept the items submerged in tanks of chilled water, mimicking the thermal conditions of the abyss. The restoration process for the 145 recovered daguerreotypes and ambrotypes became a multi-year project of microscopic cleaning. As the tarnish came off, the collection revealed itself to be a statistically significant cross-section of 1857 society. The images provided a visual census of the California gold rush, preserving the faces of miners, merchants, and families with a fidelity that exceeded written records. While the scientists worked to stabilize the physical history, the project managers were locked in a battle to stabilize the legal ownership. The injunction shifted the fight from the Atlantic to federal court, where everything turned on whether the wreck had truly been left behind. The underwriters insisted that an insurance payout preserved title across time. The salvors answered with a century of silence. No search, no recovery, no presence, arguing that title without action was abandonment in everything but paperwork. The legal proceedings required the court to navigate a new frontier in maritime law. Traditional salvage doctrines were born in shallow water, built around physical presence at the site. The Central America was beyond that world. The salvors argued for constructive possession through continuous remote control. By keeping a constant working presence with the ROV Nemo and its sensors, they claimed custody could be extended down the tether. The court's reasoning recognized that deep water technology could establish control and exclusion, even where human bodies could not go. The final adjudication recognized that the insurance claims carried weight, but it also confronted the brutal economics of the deep. In a landmark salvage award, the court granted the Columbus America Discovery Group the vast majority of what had been recovered, about 90%, reflecting the risk, the innovation, and the cost of reaching the site at all. The remaining share was reserved for the underwriters to the extent they could prove their entitlement. The message to future deep-water operators was unmistakable. If you pay the price to reach the abyss, the law can recognize that price. The legacy of the SS Central America extends beyond the auction block or the valuation of the gold. The operation proved that the deep ocean is no longer an inaccessible sanctuary. The ability to locate a specific debris field in the open Atlantic, land a heavy work vehicle on the site, and perform delicate archaeological work with more than a mile of water overhead shattered the previous ceiling of marine engineering. The ship of gold is now a mapped and visited coordinate. Its commercial cargo returned to the surface economy, its human history cataloged in museums. The pressure never eased. The difference is that it stopped being a lock.